Yes. See, the modern concept. So, already I defined, according to modern concept, the valency is the number of electrons lost, gained or shared with one atom, the element, in order to acquire the stable configuration of the nearest inert gas element. What is that nearest inert gas element? So, in the nearest inert gas element, see, you take any period in the periodic table, the nearest inert gas have generally octet configuration, like neon, argon, krypton, all of them will have 8 electrons in the valency shell. So I told you, I already told you that octet configuration, yes, that octet configuration is nothing but inert gas configuration, right? Yes. Explanation. See, lithium lost 1 electron to get +1 state. Potassium lost 1 electron to get +1 state. Beryllium, Be losses 2 electrons to get +2 state. So the valency is +2. Okay. And calcium lost 2 electrons to get +2 state. So I am using the state. State is nothing but valency. So if calcium has lost 2 electrons, according to the definition, the number of electrons lost, or the number of electrons gained, or the number of electrons shared by an atom with a particular atom to bond with. Okay, na? Yes. If calcium has lost 2 electrons, then the valency is 2. If, okay, similarly, when an atom gains, okay, atoms gains electrons to become anions, okay, fine. Fluorine gains 1 electron, F minus, to become F minus, okay, the valency is -1. Similarly, oxygen gains 2 electrons in generally to become O2 negative. So the valency is -2. Nitrogen gains 3 electrons to become N3 negative ion. See, previously I explained how when ion is formed, cation or basic radical is formed by the loss of electrons, right? Ca2 plus, Na plus, Mg2 plus, like that. Anion is formed by the gain of electrons. See, nitrogen has gained 3 electrons. That's why it become N3 negative ion, nitride ion. The name is nitride. Okay. But by looking at the charge, this is the charge. So by looking at the charge, you can identify the valency. See, if the charge is 3 negative, valency is -3. If the charge is 2 negative, valency is -2. Similarly, carbon gains 4 electrons. I say if carbon gains 4 electrons, then the ion will be C4 minus. Then the valency of carbon is -4. Like this, okay? But there are few important points we need to understand. That is, every element has a valency. I told you already, every element has a particular valency generally. Carbon has a valency of 4. That means carbon has a combining capacity of 4 units. Carbon combining capacity is 4 units. See, I take 2 atoms, oxygen, carbon and oxygen. Okay. Now valency, V for valency. What is the combining capacity of carbon? If combining capacity of carbon is 4 and the combining capacity of oxygen is 2. Okay, are you getting? If the combining capacity of carbon is 4, valency of carbon is 4 and valency of oxygen is 2, it means what? The combining capacity of carbon is double that of oxygen, right? That's why one carbon has to combine with 2 oxygens. One carbon has to combine with 2 oxygens. Similarly, let me explain one more example. Carbon, hydrogen. What are their respective combining capacity? Carbon has a combining capacity of 4 and hydrogen has a combining capacity of 1. It means what? The combining capacity of carbon is 4 times the combining capacity of hydrogen. Then that's why one carbon can combining with 4 hydrogens. Are you getting this? Yes. And valency of element is always a whole number. Why? Valency, how we defined valency in modern way? The number of electrons lost, the number of electrons gained, or the number of electrons shared. So it can't be fraction, right? Yes, that's why you can say valency of an element is always a whole number. Okay. And generally, do remember, metals are electropositive. Metals are electropositive. What I mean by electropositivity, sir? Electropositivity means tendency to lose electron. That's why generally metals have a positive valency, like let me tell you example, calcium Ca2 plus. It has valency 2 plus, right? Yes, calcium Ca2 plus, magnesium Mg2 plus, iron Fe3 plus, Fe2 plus, like that, right? So metals have a positive valency because metallic character means electropositive character. Okay, metals generally lose electrons. Okay, similarly opposite non-metals. Non-metals have a negative valency because non-metallic character generally comes from that behavior of electronegativity. Electronegative. Okay, so simple. Non-metals have electronegativity. Metals have electropositivity. Electronegativity means tendency to gain electron. That's why they will gain electron. The valency is negative, like Cl minus, Br minus, oxygen O2 negative. Oxygen is non-metal and the valency is minus 2, right? Yes, like that. And valency is rarely more than 4. I explained already. Valency. See, losing more than 4 electrons needs lot of energy, and gain of more than 4 electron also involves a lot of energy. So see, simply it is not easy to lose electron, gain electron. Simply energy is involved. You are going to study in the upcoming concepts. Energy is involved there. So losing more than 4 electrons or gaining more than 4 electrons is highly difficult. Yes, and when this is crucial point. I am going to explain very crucial point now. See, you know valency, but if you write that valency as a superscript to the symbol of the atom or ion, atom or the molecule, then it will become the ion. Let me explain. See, I'll explain here. I'm making small space here, okay? Or I'll write here. Better I'll write here, okay? I'm making a small space here, okay? You know oxygen, the symbol of the atom is O. The symbol of the atom is O, okay? And you know what is the valency of oxygen? Sir, you said already oxygen is non-metal. Sir, non-metals will have a negative valency. Okay, negative. How much? Oxygen valency is 2, right? 2 negative, right? So, you know this, the oxygen valency is minus 2. Oxygen valency is minus 2. Then write that as a superscript. So when you write the valency as a superscript, or you can write the valency as a superscript, then it will become ion. This is oxide ion. Nitrogen, its valency is, nitrogen can gain 3 electrons. Then write 3 minus. That will become ion, right? And aluminium, metal, aluminium. It can lose 3 electrons. It has a combining capacity of 3 electrons. Aluminium will lose 3 electrons. Then by that valency write 3 plus. So by the knowledge of the valency you can guess the charge. So if you use that valency to write the charge, then you will get the ion. Right. Let me show you few examples like that. And there is important point, note, inert gas elements have 0 valency. I told you already, inert gases, see, inert gases means helium, neon, argon, krypton, because all those atoms will have already a stable electronic configuration in the outermost shell. I told you why an atom combines with other atom to get stability. What is stability? Having 8 electrons or stable configuration in the outermost shell. Inert gases already has that stable configuration in the outermost shell. They already have 8 electrons, except helium. Helium has 2 electrons. That is also stable. So already inert gases have a stable number of electrons in the outermost shell. Then why they lose electron, why they gain electron, why they share electron to combine with other atoms? So that's why inert gases has a zero valency generally. Their combining capacity is zero. They don't want to combine. They don't have to combine. Right? Yes. The valency of element is used to write the formula of the compound. Yes. The valency of the element is used to write the formula of the compound. Let me give you an example. See, for suppose I write Na plus, okay. Sodium is a metal. It will lose one electron to combine with others. That's why 1 plus, okay. So its combining capacity is like this, plus 1. And I am taking O2 negative. Now see, it can gain 2 electrons, it can lose only 1 electron. Then think carefully. Oxygen can gain 2 electrons, sodium can give only 1 electron. Then obviously to combine with, right, the combining capacity of oxygen is 2 and the combining capacity of sodium is 1, right? That means the combining capacity of oxygen is double the sodium. It means what? To combine with 1 oxygen, we need 2 sodium. Avuna kada? Oxygen ki 2 electrons kavali. Oxygen need 2 electrons. Sodium can give only 1 electron. So, to satisfy oxygen, we need 2 sodium, na? Right? We need 2 sodium. Yes, how? Take 1 sodium atom. 1 sodium atom lost 1 electron to become Na plus. Okay, sir, fine, sir. Okay, but oxygen atom has to gain 2 electrons to become O2 negative. Right? Now, where these 2 electrons came? Sodium can give only 1 electron. That's why you have to take 2 sodium. So that you will get a 2 Na plus, 2 electron. Now add these 2 steps. 2 steps added. Okay? Arrow mark becomes an arrow mark. Okay, how to add these steps? Let me tell you. See, the same electrons here formed and here consumed. Here 2 electrons formed and 2 electrons consumed. What I need to do? That's why these are going to cancel in the final, because what happens? Something formed in the first step and consumed in the next step. Finally, they will not present in the final step. Okay, that's why you cancel the common terms diagonally. Common terms diagonally. Diagonally 2 electrons are there. So 2 Na plus O gives Na2O. So when when you are showing separately the number of atoms, you have to use this coefficient as it. There is 2 sodium, you are using 2 sodium, that's why coefficient 2. But that 2 sodium present in the compound, you have to write the number 2 as a subscript. Okay? Yes. So this is how. So I want to explain this, but in the next upcoming video, I am going to explain how the ions will combine by crisscross method. Okay? I will give you a trick to combine. I will give you a trick to make formulas with the ions. Okay? If you have ions, then you can simply make the formula with them. Fine? Yes. Now you can see simply how a monovalent anions, how we can express a monovalent ions with their valency. I'll explain a few examples, like if you take NO3 minus. So the charge is -1, right? The charge is -1. So with this you can identify its valency. It is monovalent, like BrO3 minus monovalent, ClO4 minus monovalent. Valency is 1, charge is -1. Monovalent anions. You can look at, you can go through all these examples. You are not supposed to by heart them. Okay, you get familiar with them slowly. Okay, you are not supposed to by heart them. At least few important, like bromide, chloride, iodide. See, let me tell you one thing. Cl minus bromide, Cl minus chloride, Cl minus chloride, Br minus. Generally, we are using the term minus. The perfect term is Cl negative, chloride, Br negative, chloride, I negative, iodide, H negative, hydride, N3 negative, nitride, S2 negative, sulfide, O2 negative, oxide. So generally what we are doing, if a single atom is having charge, we are using that ide to the name of the ion, okay? Hydride. So this is hydroxide, okay? And there are separate names for some ions like SO4 2 negative. This is sulfate. SO3 2 negative, sulfite. This is sulfite. This is sulfate. Okay, why this name 8, why this name 8, you will learn slowly in the upcoming classes. You are not supposed to by heart them, but get familiar with this. Okay, these are monovalent. Okay, and what about divalent? Some divalent species I have given here. Okay, SO3 2 negative. This is the charge. Okay, so charge is 2 negative. Charge is minus 2, charge is minus 2, and the so you use that minus 2 charge to identify the valence. It is bivalent, CrO4 2 negative. Look at this ion, what is the charge? 2 negative. So valence is 2, bivalent 2. Valence is 2. Like that trivalent anions also, N3 negative, PO4 3 negative. Okay, so charge is minus 3. And the valency you can understand, it is 3 negative, trivalent anion, fine. And see, there is some important thing like oxygen. See, oxygen, generally when oxygen O2 negative, this is oxide, okay. When oxygen like this, O2 2 negative, see, O2 negative, O2 2 negative, here one atom has gained 2 electrons. One atom gained 2 electrons. But here 2 atoms gained 2 electrons, means one atom 1 electron here. This is a peroxide. Important thing, okay? Yes, remember, it is very important. And sometimes there is 2 oxygen, but overall gained 1 electron. Okay, this is superoxide. See, what the thing here is, one atom gained 2 electrons. That means that 2 electrons gained by one atom only. That is oxide. Here, there is 2 atoms. 2 atoms each gained 1 electron. That is peroxide. And this is very special and very rare also. Only 3 examples you will find. Okay, only 3 examples you will find. Okay, in the upcoming classes. Okay, like potassium peroxide, superoxide, rubidium superoxide, cesium superoxide, like, okay. These are the 3 examples you will find generally for superoxides. Peroxides have some more examples, better examples, H2O2, Na2O2, BaO2. In all these are examples for peroxides in which oxygen exists as O2 2 negative. And the most abundantly available oxygen anion is oxide. So generally, mostly oxygen exists as oxide, okay, and some examples it will be peroxide. Generally, mostly oxide, some examples it will be peroxide, rarely superoxide. And what's the difference? Here one atom gained 2 electrons, here 2 atoms gained 2 electrons, means each atom 1 electron. Here special, there are 2 atoms, both have gained 1 electrons. That means 1 electron per 2 atoms. That means each electron get half share. That way you can think, okay? Yes. Okay? Yes. I hope you understand this concept of modern concept of valency, the combining capacity. Okay. We are going to meet in the next video with the concept called variable valency. That means some atoms has variable valency. See, among these previous points, at one point I explained you, for an element, every element has a fixed valency, right? Like carbon valency is 4, like carbon valency is 4, nitrogen valency is 3, like that. Generally, for most of the important elements, valency is a fixed value, always. For carbon 4, like that. Halogen, like chlorine, the valency is 1 generally. But there are some examples, or there are many examples where one element has more than one valency. Okay, that means valency can be variable. One element showing more than one valency, that is called variable valence, and very important concept that I am going to explain in the next video. Stay tuned. Thank you.